So we're going to continue our work in our Unit 6 review here. In this example 2, we are going to use two basic rules to solve a single integral. So when you see something like this, it sort of looks like one of our arc rules. It looks kind of like an arc sign, but we're not quite there yet because we have that extra x in the numerator, and it also kind of looks like a u substitution. So I'm actually going to end up using both of those rules when I do this one. So, and it's a definite integral, so I'm going to have to evaluate it just a little bit further. So I'm going to go from 0 to 1 and I'm going to take and just split it into two fractions with the same common denominator. So x over the square root of 4 minus x squared dx plus the integral from 0 to 1 of 3, and I'm going to move the 3 outside, 1 over the square root of 4 minus x squared dx. So I'm definitely now much more seeing a u substitution here. So my u looks like it's 4 minus x squared. So that means that du is equal to negative 2x dx. I don't have the negative 2, so I need to add a negative 2 inside and a negative 2 outside. And then I look like I think I'm ready to actually do my u subbing because I have every other part. So I've got negative 1/2 the integral of, I need the fraction bar in the square root. I'm going to put u under the square root, and then my negative 2x dx is 1 du. I am going to bring my u upstairs by making it so I know it's u to the 1/2 power, and then to bring it upstairs, I make it negative du. And when I go to integrate that, I get negative 1/2 u, and I'm going to plus 1, so that's going to make it 1/2 divided by 1/2 or multiplied by 2, or 2 over 1. And then I know that this simplifies, and I'm going to keep doing my work over here. I've got negative u to the 1/2. Now, it was technically a definite integral, so I do need to evaluate this. But since it's in u's, I'm going to go ahead and I'm going to try to figure out what my values were supposed to be in u's. So I'm going to plug this into here. So I've got u of 0 equals 4 minus 0 squared, so it's just 4. So I know all my lower limits were 4. And then I'm going to put the 1 in. So I've got u of 1 equals 4 minus 1 squared. Oh, look, it's 3. So really what I should have done back over here, because I should have put those limits on sooner, was I should have flipped it and flipped the sign, right? So really what should have happened was I'll do it in red. I should have flipped this to the 3 and this to the 4 and then swapped to a plus sign. So the good news is that takes care of the negative in front. So when I go to plug those in, I've got 4 to the 1/2 power minus 3 to the 1/2 power, or 2 minus the square root of 3. Now I have to do the integration of this piece here. This definitely looks like an a squared minus a u squared, where your a is equal to 2 and your u is equal to x. So we've got 3. This is an arc sign, right? It fits this formula right here. There's no 1 over a out front, so it's just 3 arc sign of u, which is the x, over a, which is the 4. And then we're going to go from 0 to 1. So I'm now going to start plugging in. So I've got 3 arc sign of 1/4 minus 3 arc sign of 0. And this is kind of weird because normally we normally have a pi in there. So I think that maybe there's possibly something missing in the problem. So we're going to pretty much stop right there. So 3 arc sign of 1/4 minus 3 arc sign of 0 at the end. So all of this would have been the same work all the way down. we're going to do one more here. So we're going to do a substitution problem that involves both a squared and u squared. So this is a slightly different looking substitution problem. Notice it's looking like an arc sine again. So let's rewrite it just a little bit. Let's say I've got x squared over the square root of 4 squared minus x cubed squared. That's definitely now looking more arc sine-ish, right? So our u value in the arc sine, and notice I'm switching to orange on purpose because I do have a little bit of a numerator there. So our u value is going to be x cubed. That means my du value is going to be 3x squared dx. Well, you notice that there isn't the 3 is missing. I have x squared dx. I need a 3 on the outside or inside, which means I also need a 3 on the outside. So I have 1/3 the integral of 3x squared dx over the square root of 4 squared minus x cubed squared. So it looks like I definitely have all the parts. I am ready to integrate. I probably didn't need that line. I'm ready to use substitute. So I've got the square root of 4 squared minus u squared, and then my numerator is just going to be 1 du. Now I'm definitely an arc sine, so I'm ready to integrate my arc sine. So it would be 1/3 arc sine of u, which is a u this time, over a, which is the 4, plus c. And we would go ahead and substitute back in the u that we originally had. So it'd be 1/3 arc sine of u, which is the x cubed over 4 plus c.